All right, I have returned. I have uniform duty, which I have decided to call fashion police, which is sometimes awful, but a lot of times really entertaining when people are frustrated about it. Just doing my job. All right, let's see. So with a little cunning in calculus, we can evaluate the slope of an inverse function that we can never actually find. So if we look at this, x cubed minus 3x plus 4, if we look at the graph of this, you're going to see what we're talking about here. Let's see. X cubed minus 3x plus 4. That is not right. Okay, don't do what I did. You don't want all that to be in the exponent. X cubed minus 3x plus 4. All right, now if we go to graph. All right, and okay, so I want to get this back to the normal window. If I hit zoom standard, it'll bring it back to my normal window. All right, we can see here, that's an issue. If we were to try to invert this, its inversion would be like that, kind of turned on its side, like that, which, like, you know, that's a cool design. It looks neat, but the problem is right here, it fails the function test. So we wouldn't be able to actually invert that. So what we're going to need to do is utilize our special formula. So our special formula, remember, it's magnum PI, so prime inverse. So it's going to be, I'm just going to write the formula first. The formula for this is 1 over prime inverse of 6. Now, finding this is going to be the challenging part here. So all I'm going to do is I'm going to start all the way in here and try to work my way out. And the first thing that I want to reiterate is that x's and y's are switched with inverses. So for example, if we're looking at f of x versus f inverse of x, and we had an xy table. So right now, it's telling me that we want to know what f inverse is in, blah, blah, blah. Hey, I'm going to try that again. Right now, we're trying to find the derivative of f inverse at 6. And the formula says, well, hey, whatever the y value is for the inverse when x is 6. So it's going to be 6, and then I'm not sure what this is because I don't know what the inverse is. I can't just plug 6 in here because I don't know what this is. But what we do know is that if this is an x value in the inverse, then it was a y value in the original. And so if I find out what x value gave us this y value, then I can swap these here. And so whatever that is, that's going to be. That's the leap, and that's really where this word comes in. This is sneaky. So what I'm going to do is I'm going to take this function here. I'm going to say 6 is equal to x cubed minus 3x plus 4. And I'm going to solve this by hand. Just kidding. I'm going to use my calculator. Ow. So in trying to be like dramatic, I slammed my calculator on my finger. I'm an idiot. Okay, so if we go in here, oh, I already have it graphed, great. There's a couple of ways to do this. One way would be to set this equal to 0 by subtracting the 6 from both sides. Another way is finding where these two sides intersect. I'll show you both just so that you can kind of take your pick. So I write one side in y1, I write the other side in y2. I'm not trying to flip the camera off right now. I'm pointing with my middle finger, sorry. So I go in here. All right, so it looks like we may have two separate intersection points. Let's see. So if I go to second calc, I can do intersect. And it says first curve, you really hit anywhere on your first curve. Second curve, you hit anywhere on the line. And then guess. With this calculator, you really want to kind of get it close to whichever one you're Like if you think there are two intersection points. Oh, okay. So since it was over here, it checked, and I guess it didn't work. So x is 2, y is 6. Another way, so I'm gonna just show you really quick that you can get this doing it this way as well. So instead of doing that intersection thing, you can go in here and you can change this to, setting it equal to 0, graphing it and looking, it really looks, hold on, I'm just gonna, so using the 0 function, it looks like we get a 0 here. Okay, so it really looks like at -1 we get a 0, and I'm just going to double check. Yeah. So there are actually two values here. So we'll kind of cross that bridge when we get to it in a minute. So let's see. But yeah, second 0. So defined as 0, it says left bound. That means you push enter somewhere to the left of where you think the 0 is. Then you move the cursor over somewhere to the right of where you think the 0 is. And then guess, you don't actually need to move the cursor for guess. You can just push enter I said just. You can just push enter at that point. So we got 2, 6, and the -1, 6. Remember, the y value here doesn't mean anything like to this original function. That's why I think the intersect way of doing it might be a little bit better. So, okay, so these two different x values give us a y value of 6. That means that over here, there are two different, so 6, 2, and 6, -1. So there may actually be two different answers that we need to find here. So, and it just says 1 over f prime of bleh. Do I have an extra parentheses? I do. That shouldn't be there. For every parentheses we open at the end, it should be closed somehow. So that was an extra. Maybe it was around the whole thing. Anyway, so let's see. So that's 1 over f prime of f inverse of 6. Well, that could be 2, or 1 over f prime of 6, which is, f prime of f inverse of 6, which is -1. Really weird how this works. Like I said, please make sure that you don't cry on your screen or anywhere that is, having electricity go through. We don't want anything to fry any circuits. So the good news is these are both very easy to find, because this is just saying f prime of that. Well, f prime of that is just 3x squared minus 3. So f prime of 2 is just 3 times 2 squared minus 3, and f prime of -1 is just 3 times -1 squared minus 3. So here we get 3 times 4 minus 3, so 12 minus 3, so we get 9. And here we get 3 times 1 minus 3, so 3 minus 3, so 0. Aha! Pardon me. So anyway, when we go back up here, well, f prime of 2 is just 9, so we get 1/9. So that could be the derivative of the inverse at x equals 6. Or 1 over 0. Whoops, that's undefined. Remember, 1 over 0 is undefined. So we can say that the inverse's derivative at 6 is equal to 1/9. Please don't ask me why. I don't know why we need this. I'm sure that there's an application to this. I'm sure that this has a real-world physical application, but I don't know it. All right, so we'll do another example. It says if f of x equal to x to the fifth plus 2x cubed minus 4, find the inverse. So let's just let's look at this again. It's really good when we have the opportunity to look at what our graphs look like. So let's see. Sure enough, that little crook in there right there, that's going to probably mess with our inverse. But I actually don't even need the inverse, because remember, our Magnum PI formula tells us PI, Magnum PI. So I kind of do these the same way every time. I go, okay, well, if I know that the inverse has an x value of 10 and a y value of I don't know, then my original has a y value of 10 and an x value of I don't know. For me, this is the easiest way to remember the steps of setting this up and going through and doing it. Using that concept of every time we're looking at an inverse, the x's and y's are swapped. So when we go in and we handle this, I'll take my original function. I'll say, okay, well, y is 10, x to the fifth plus 2x cubed minus 4. I did the same thing I did last time. I slammed the calculator down on my hand. Go me. And I'll set it equal to 10. And I'll graph, and it looks like there's only one intersection point here. So that's definitely going to chill things out a little bit. So if I go to intersect, first curve, second curve, guess. Oh, good, a super nice number. So recommendation at this point, 1.49105557. Put the whole, like, as much as you can write down, put it all in there. Don't round until the very end. The calculator is going to do a majority of the legwork here, so you don't need to complain about doing that. Just make sure you don't make typos when you're writing or when you're handling it. So we know x is 1.4910557, which means if we swap them, we get the inverse's value, 1.4910557. Cool. So that really means over here we're looking at 1 over f prime of, remember this says f inverse of 10. That value right there, 1.4910557. So f prime of that, well, f prime's just take the derivative of that, right? 5x to the fourth plus 6x squared. Oh, that's it. And look, no reason to do this by hand, because we needed the calculator to solve. So I'm going to use the calculator here. So 1.4910557 to the fourth plus 6, 1.49105557 squared. All right. So the derivative, so f prime of blah is that. So I can say 1 over 38.0536209. So real nice way to do this in your calculator, put 1 divided by second. Oh, no, you can't see me typing. Okay. Real nice way to do this in your calculator is 1 divided by second answer. So it'll just take that decimal, put 1 over it, and we got 0.026. So to finish this up, I'd say f inverse prime of 10 is equal to that. I used Magnum PI to solve it. Okay. Final example. All right. Oh no, this sounds like an AP style question. Why is it in Comic Sans then? I don't know. All right. Let f be a differentiable function such that f of 3 is equal to 15, f of 6 is equal to 3, f prime of 3 is equal to -8, and f prime of 6 is equal to -2. The function g is differentiable and g of x is equal to f inverse for all x. What is the value of g prime of 3? This is a fantastic question because it doesn't require graphing. It doesn't require any of that. It just requires us to understand the same stuff that we had to understand in the previous problems where, okay, I took a function and I knew that the mapping there where the x's and y's get flip-flopped. And so if we use that same logic that x's and y's get flip-flopped, well, then we know that if for f of x, we make an xy table, we know that if x is 3, y is 15, and if x is 6, then y is 3. So that then tells us that f inverse of x, which secretly is g of x, that is then flip-flopped. So 315 turns into 15.3, and 6.3 turns into 3.6. So when it asks what's g prime of 3, this is asking what's the inverse's derivative? What's f of x's inverse's derivative at 3? And we can just use Magnum PI, which is 1 over Pi. The cool thing is, I know that f inverse of 3 is 6 then. So it's really saying 1 over f prime of 6. Oh, I wish I knew what f prime of 6 was. Oh, there it is. Turns out it's 1 over -2, and we're done. So memorizing Magnum PI, prime, then inverse, really is going to help you. It's another derivative formula. Yeah, I hope this was helpful. Well, please like, share, and subscribe, and leave a comment.